So, 4.1 billion years ago, we have the Earth, right? The Earth is here. 4.1 billion years ago. We're asking, where does life come from? How did humans get here? Right? Everybody keeps asking that question. That's a great question. How did we get here? The answer, the answer is chemistry, a mixture of biology, chemistry, physics, and the laws of physics, right? Essentially. But 4.5 billion years ago, the Earth forms. But let's fast forward, okay, to life. How did life get here? It seems like there's something about life that is so unique from the rest of the world, right? It's like we seem animated in a way that a rock isn't. We seem to be something different than rocks, plastic, cars, right? We're different. Well, that's because each organ in your body contains thousands, billions, and billions of cells, each working together biochemically, interacting with each other in very microscopic levels, giving rise to your senses, giving rise to your heart beating, your lungs moving in and out. And so you are essentially a universe of cells. Each and every side, inside every one of you is a universe of cells operating in fantastic ways. So, to understand the origin of life, you have to understand what life is. Life is a biochemical system, very complicated system. Now, where did the first but how did this all start, right? Well, of course, if you go back in time, life was much more simpler than today. We are complex. The first living organisms were much more simpler. And through that time went over time and death, sequences of evolution, you get us. Remarkable. So, the first living organisms were cells. They're very microscopic cells, individual cells that within themselves were able to replicate. Okay? Interacting, the first protocells, they replicated interacting with each other. But about 4.1 billion years ago, we have the first cell that can replicate on its own, coming from amino acids, coming from lipids. These things form in the atmosphere. These things form in the oceans with ammonia, methane, these kinds of molecules. They can actually give rise to the building blocks of life itself. And water facilitates these reactions, especially water near hydrothermal vents, which is an energy source, and especially near hydrothermal vents under the seas is a package of complicated chemistry, iron, nickel, all these different types of elements interacting in very complicated ways, facilitating the process of life. So, 4.1 billion years ago, we have the building blocks, lipids, sugars, amino acids. They form, again, from atmospheric things and water. And we have the first protocells. Now, there's a few different hypotheses as to how this could happen, right? One of the main ones is the RNA world hypothesis, which says that, well, DNA wasn't there, right? DNA is a strand, right? We all have DNA in our bodies, billions of atoms. That's how big the molecule is. But obviously something preceded this. It was a precursor to DNA. It was RNA. And RNA is a very much simpler form of DNA. It can replicate. And so scientists believe that this is one of the first molecules that give rise to life. And so when you have this kind of molecule encompassed by a lipid bilayer in the oceans, you get a protocell. It's much more complicated than that, but this is the basics, right? So how do we get the tree of life from this point, right? Because in order to understand how we have so many different a diverse array of animals on the planet, right? Plants, animals, sea creatures, dogs, the amount of diversity is amazing on the planet. But how do we get all this complexity? How is it that simple cells can create such a complicated array of organisms? Well, because life is a tree. Think of life like a tree. See how it branches out? See how a tree branches out and just keeps on branching. But if you trace all the branches back, you find that they all share a common stump. They all share a common beginning. That's the first protocell. The first protocells were there. And then over time, through evolution, natural selection, various other mechanisms of evolution, you have the tree of life, in which you have all the organisms representing their own branch on the tree. See? And so the closer the branches are to each other, the more related they are genetically. The further away, the less related they are genetically. So, again, our ancestors, 4.1 billion years ago, the very first ones were those very primitive protocells. That's where we come from. Think of a never-ending tree that just kept growing to today. We are the tippity top of the branch. And so are all living organisms. We are the top of the branches. We're the most outer branches of the tree of life. And everything before us is within the tree. So, about 800 now life on Earth was single-celled for about 2 billion years of history went by. In fact, about 3 billion years, life on the Earth was purely single-celled. There were no multicellular organisms. There were no animals. There were no plants. From 4 billion years ago to about 800 million years ago, life was just bacteria and archaea, very primitive forms of life. But about 800 million years ago, multicellular life emerged. How? Well, these single-celled organisms found ways to communicate to each other and interact with each other. That made them larger. The larger ones survived. They went on to continue, right? And evolution occurred. The same natural selection that dictates how we evolve apply to these guys here. 600 million years ago, this is when we have the first animals. Okay, the first animals with specialized organs. Very primitive, yet again, very primitive organs, but they were organs nonetheless. They had bodies. They had sensory systems. Some of them had very primitive neurons. And so this is when, why did they develop these things? Because it helped them survive. It helped them find food. It helped them outcompete their competitors. See? That's, again, basic. This is the basics, but this is the point. Some of our ancestors were worms about 600 million years ago. Our closest ancestors 600 million years ago were worms. They looked kind of like that. They would dig under them. They would live near the surface of the oceans, bottom feeding on dead bacteria, dead organisms, feces, anything they could find, they would eat. And 500 million years ago, fish, those worms evolved over many, many generations. They evolved to be more complicated through evolution, natural selection. Here's one called Hyquicthus. Hyquicthus. One of the first fish that we come from. Now, they didn't have jaws yet. They weren't the predators we see today, like sharks. They were very primitive early fish. And yeah, that's our ancestor right there. That's what they had, some vision and touch capabilities. They had some primitive form of consciousness. As we know, consciousness is a physical thing. It happens in the brain. But early fish had that. Very primitive form of consciousness. Why? Because it helped them see further. It helped them look for food better. It helped them look for predators better. The eyes are connected to the brain, directly connected. And so consciousness was highly important for these early organisms in the oceans. Then about 350 million years ago, fish, as they evolved, they got way more competitive in the oceans. They began to evolve jaws and specialized teeth, and they got more rigid and had stronger bodies. Some of these fish, in order to outcompete their competitors, in order to survive, they began seeking the grounds, the land. Some of the fish, using their fins, over many generations, they went further on land, right? They would come up from the oceans, barely get there, barely crawl to land, lay eggs, or, do whatever, eat, lay eggs, whatever, and then go back to the oceans, right? And then generations would go by, and these organisms, the ones who could survive, who could do that better, live outside better, they continue to survive. They pass down their genes, and so they got increasingly better at living on the land. Right? That's how this happened, essentially. It's not like one day fish just suddenly started walking with two legs, right? It's obviously way more complicated, but that's just the basics. So we had the first amphibious creatures, very not amphibians as we know them today, but very amphibious-like. Tiktaalik is one of the first land animal ancestors that we all have in common. In fact, almost all animals on the planet have that same ancestor, Tiktaalik, one of the first land creatures on the planet. It wasn't a fish, it wasn't an amphibian, it was something in between. But about 350 million years ago, as more land animals continued to evolve, there was a major splitting in the tree of life, a major branching between the synapsids and the sauropsids. Sauropsids. The synapsids and sauropsids. The synapsids became us. The sauropsids became the dinosaurs. Okay? So these guys were not quite reptiles yet. They were very in between amphibians and reptiles, right? So that was the stage they were in 350 million years ago. So our ancestors look kind of like this, right? They were not quite amphibians. They were not quite reptiles. They were something in between, transitional stages of those types of animals. One of them called Archaeopteryx, about 300 million years ago. Okay, 250 million years ago, one of the first mammal-like animals. The synapsids, some of them branched out to become mammals, mammal-like, increasingly mammal-like. They became a bit more warm-blooded. They adapted more to being on land, living in trees, because this is some of the time when trees began to become prevalent on land. Trees didn't exist until about 350 million years ago. And so our ancestors used the trees to hide, to lay eggs, right? Some of these creatures, some of these early mammal-like animals laid eggs. They didn't give live birth like we do today. And so, again, they're slowly, gradually becoming mammals, right? About 250 million years ago. But then about 160 million years ago, we see another branching in the tree of life. Some of the first mammals, our mammalian ancestors that were very small. These guys gave live birth. They were becoming nocturnal. They had certain features that resembled mammals, like today. Very primitive one called Morganucodon. Was that one of our first mammal ancestors, 160 million years ago, living amongst the dinosaurs. Again, during this time around the Earth, dinosaurs are dominating. Okay, dinosaurs, not T-Rexes yet, but mainly the sauropods, those big guys that walked on all fours. Those guys were dominant. Some carnivorous, two-legged dinosaurs, but these guys were small because they were competing with the dinosaurs. They had no choice but to live under the tree trunks, live underground. They were hiding from the dinosaurs because they were the predators. Dinosaurs were preying on these little mammals. Some of the dinosaurs were also small, maybe like turkey-sized. They would prey on these tiny little mammals, the ones that the ancestors that made us happen. But we would eventually get a revenge. Okay, about 70 million years ago is when Purgatorius, a particular mammal, our mammal ancestor, this guy was a badass. He survived the dinosaur impact. So we all know about 66 million years ago, the dinosaurs went extinct. Why? Well, the big asteroid came by. It lifted up dust and air debris into the atmosphere, blocking out the sun for a decade. It got cold. Plants died. A lot of animal life died. And as the food chain collapsed, the dinosaurs, the ones that were largest, died first. Right? However, the smaller mammals, like Purgatorius, okay, he survived. Why? Because he was smaller. He was able to survive underground where it was warmer. He was able to eat seeds and nuts. And the reason why that's important is because there was no food. Okay, there was like no food for these animals to consume. That's why the dinosaurs died out. But this guy, the dinosaurs couldn't eat seeds. They couldn't eat seeds. They wouldn't extract anything from that. But these guys, since they were living in the trees, they adapted to eating tiny seeds and nuts. The thing about seeds is that they can survive extremely cold temperatures. They have hard shells surrounding them. They can also live underground, right? They can find their ways underground, and they can, yeah, it might be very cold on the surface, but thousands of years later, they can germinate. Okay? And so the point is that these guys had lots of seeds available to them because these seeds could persist throughout all the chaos. So most of the dinosaurs died out. Some survived, right? Birds. By the way, birds are dinosaurs. But most of the dinosaurs died out. Most of the animals died out. Purgatorius, our ancestors, survived. And the beautiful thing about that is that Purgatorius came out of that extinction event winning. Like, he now had a better chance at surviving because the dinosaurs were gone. They were no longer preying on the Purgatorius. And so they began living in the trees. They began dominating in the trees. That was their niche, their new niche. They would crawl up the trees. They would eat the seeds and nuts, right? They were tiny. They were like this big. They were like a size of a mouse. And so they didn't need to eat so much food. See, like those big T-Rexes, right? Those big dinosaurs, they had to eat like hundreds of pounds of food per day to survive. Like, the bigger you are, the more you got to eat, right? And so that's why all the dinosaurs died out. They had no food. But this guy, Maybe he eats like a couple seeds a day and he's good. And so they were thriving in the trees. They were eating more and more. They got larger and larger. They weren't being preyed on as much. Being larger made them survive better. Okay. Now they could fight against birds who try to attack them, or little reptiles who tried to attack them in the trees, right? So, the first primates occurred. This was the first actual proto-primate. It's debated, but this is one of the first primates, essentially. About 65 million years ago, okay? Now, funny fact, Purgatorius lived in Montana. Well, that was the main area they lived in. Canada, North America, but primates, our primate ancestors began in America. We began in America, essentially. But back then, 60 million years ago, it was way warmer back then, right? And so there were tropical forests in Montana, right? Even in Alaska, there were tropical forests. There were no ice caps at this time. It was really warm around the entire planet. So, this guy came out of the extinction with lots of food, lots of land, very little predators. And he was eating fruits, nuts, and seeds. And by the way, fruits were important because fruits had lots of sugar. Sugar is energy. And by the way, fruits were something that dinosaurs didn't see much of. Fruiting trees were new, relatively new about 70 million years ago. They were relatively new. And so the dinosaurs could not take advantage of that. These guys could. Since they survived the extinction, they had lots of fruits and food available. And 55 million years ago, Archicebus, a bigger primate, a little bit bigger, starting to look like a monkey. The tails get larger. Why? Why are their tails getting larger? It helps them move as they jump through trees, jumping on branches. It helps them become stable when they're running across these trees, through the trees. See? Their tails become larger. Their hands become a bit more graspable because you can pick at the fruits better. See? The ones who were able to pick at fruits better survived. The ones who couldn't, they died out, right? So that's natural selection. They also began consuming insects. Now they could grasp. Now they're better hunters in terms of that. They evolved fingernails. Their hands became more specialized. Okay. They became more touch sensitive. You know, see how your hand, most of your hand, you can sense very well. Very sensitive area, right? That evolved in the trees 50 million years ago when we were trying to handle fruits and handle branches and handle our food. 40 million years ago, Catapithecus, another primate ancestor who is even more monkey-like. Okay? Tail's even bigger. Fur. Climate's getting a bit colder. Okay? The fur develops. Their arms become longer so they can reach the trees. They can reach the tippy tops of the tree branches. Extend their arms out to reach for the fruits. Their eyes become better at depth perception. Okay? As they move through branches, the ones who could do that better survived. The ones with the better eyes survived. Okay? 30 million years ago, Egyptopithecus. Okay? Now, mind you, a lot of these guys, our primate ancestors, moved across America. They migrated, we're talking over millions of years, right? They migrated into Asia. Because back then, there was a land bridge. They could do that. It was connected. America and Asia were connected. And so these guys are able to thrive all across North America and Asia and now Egypt. By the name, you can tell Egyptopithecus, this guy lived in Egypt. And so the first African primate ancestors began to live back then. Now remember, Egypt back then was not dry. It deserted like it is today. It was a swampy jungle back then. Okay. Okay. But 30 million years ago, the climate began to change around the planet. Remember, we're on a long-term cooling trajectory because of geological reasons. Ice caps are beginning to form at this time. About 30 million years ago, we start seeing ice caps form. The polar currents lock in cold at the poles, and ocean currents facilitate all this. But the point is that our primate ancestors began to develop their vision, their color visions, because they were living more during the day versus at night. See, before this time, our ancestors who were tiny were sleeping during the day. They were sleeping in their trucks to hide from the dinosaurs who were hunting, right? So they were active at night looking for food. That's why they had whiskers. That's why they were good at smelling. Because at nighttime, there's no light. You need to depend on your whiskers, and you need to depend on your sense of smell to find food. And so, however, at around 25 million years ago, that began to change. We started living and hunting for our food more at day. And so we depended on our vision more and more, not our whiskers. Our whiskers started to get smaller. Our vision became more colorful. We can see further. And we began living in larger groups together. That helped us survive, right? Because if you live in a group together, you can watch each other fend off predators easier. Oh, look, you can say, predator, right? You can scream if there's a predator. Ah, predator, right? You can all scurry up to the tree. See? That's called the many eyes hypothesis. Living in larger groups allowed these ancestors to survive even when there were predators present. This social environment enhanced their intelligence. It's a feedback loop of intelligence for these guys because, well, living in larger groups means you need a larger brain to understand this social atmosphere. That enhanced our brains. Vocalization became more complicated, right? Vocalizations to warn off from predators. We began to pick for lice and all these things. We became more socially lubricated. They was all key for their survival. Everything they evolved and adapted to was key for their survival. Okay. Now, 20 million years ago, we have something incredible happen. Proconsul. Proconsul was the first ape ancestor. This guy was a big guy, about 50 kilograms. It's like 100 pounds. He was a big boy. But why? Well, Proconsul lived in Africa. He lived in Eastern Africa. And there was lots of food there. Very little predators, and they lived in the trees. They weren't jumping, though, from branch to branch anymore, okay? They were just sitting on branches and reaching for food, reaching for fruits, reaching for things like that. They would rarely come down from the trees. They slept in the trees, they lived in the trees, they ate in the trees, okay? And so they began grasping onto branches, and so their fingers became more graspable, their thumbs. If you notice how you do that, why? It helps you grasp things. It helps you grab onto branches, okay? That's why they developed those types of hands with opposable thumbs, okay? It helped them survive and adapt in trees, okay? And because they had more body weight, they couldn't just step on these smaller branches. They would break, they would fall, right? So what do they had to do? Well, they had to hold on to a top branch and position their bodies in a way that wouldn't break the bottom branch. So they had to become more delicate in the way they moved. Their tails shrunk. They don't need the tails anymore. They're not running anymore through the trees, right? They're just climbing through them like this, okay? And so that's why they developed their hands. Their their fingers got longer. Their wrists became more mobile. Their stiff shoulders became mobile more, right? Now, why is it that I can rotate my shoulders like this? Dogs can't do that, right? They just do this, right? Why? Well, it's because the trees. I can do anything in a tree. I can grasp onto any branch I want, 360 degrees around me. That's vital for survival in the trees. That's why they developed that, right? Here's a good graphic for that. Okay. So, they lost their tails, their body sizes became larger, and now they wouldn't be predated on by the amount of predators they had decreased as they got bigger. They would do that, right? They would just do that through the trees using their arms. Okay? They ate mostly fruit, 70% fruit, 30% leaves, and the occasional insect, right? That was their diet. That's it. Leaves, fruits, and insects. Now, 17 million years ago, we're starting to get more human-like, okay? Eastern Africa, tailless, rotating shoulders. But 12 million years ago, something strange happens. There's an African-European land bridge. Greece and Turkey, Europe becomes warmer. There's a region, there's a time period where Southern Europe becomes warm, and some of these ape ancestors migrate into Europe. Yeah. One of the first ones, our ancestors, was, I think, called what's it called? Dryopithecus, about 12 million years ago. Dryopithecus lived in Greece, in Turkey. They left Africa about 12 million years ago, right? Our ape ancestors. And they migrated towards the southern part of Europe. Why? Food. The fruits were juicier up there. There was more. It was a fruit paradise for these guys in Europe. Because in Africa, the fruits are special. Fruits like bananas, for example, right? They don't grow at the tips of branches. They grow like near the trunk, right? However, in Europe, what do you have? Plums, cherries, grapes, right? All these delicious, juicy fruits that you can just sit there and pick it out all day. And that's what these guys did. They survived in Europe. From 12 million years ago to 9 million years ago, our ancestors lived in Europe. But then about 8 million years ago, it gets colder, the climate. Forests begin to shrink. The fruit begins to be less and less plentiful. Auranopithecus, another ancestor, adapted to eating tougher foods. See, our ape ancestors began noticing that there were plants in the ground. Tubers, potatoes, nuts. Those were the plants that survived the colder climates. And so their teeth and jaws became stronger to handle those tougher foods that they had to eat to survive. Their tooth enamel became stronger. Okay? Their jaws became stronger. They were living all around Europe and Africa. However, there was one particular group of Auranopithecus about 8 million years ago that went to the western side of Africa. Another group went to the eastern side of Africa. If you can see here, the western side of Africa was a tropical paradise. The climate was beautiful, and there was lots of food. So that group of ancestors were happy in West Africa. However, the group that went to East Africa got screwed. But it actually helped them in the end, because the ones that went to East Africa, they found themselves in the middle of the African Rift Valley being split apart. And it got drier there. It got so dry in Eastern Africa. Trees became so sparse. However, they were trapped in Eastern Africa. Oh my God, these people are ridiculous in the comments. Shut up and learn. Shut up and fucking learn. Okay. So the Eastern Africa was dry because the splitting of the East African Rift Valley was splitting, forming mountains. Mountains were blocking moisture from the eastern and western side of Africa, from the Atlantic and the Indian Oceans. And so what happens? You get very dry conditions in Eastern Africa, but they were stuck there. They had no choice but to survive. How did they survive? Well, they began walking. That's the key to humanity, walking. So as trees became more sparse, as jungles dwindled in the eastern side. Remember, the western side, the apes there were happy. They became later on chimpanzees. That's where the chimp and human divergence occurred about 7-8 million years ago. They became the chimps. The ones who were comfortable in the west, the ones who were not comfortable in the east became humans. Okay? So our ancestors began walking more and more on the eastern side of Africa. They had to walk to the food. They had to walk to find food to survive, okay? And so that's what they would do. They would get on foot and walk further and further over many generations. The ones who could walk further survived because they could find the food and the water, okay? And so, however, they were terrible walkers. About 5 or 6 million years ago, walking was not the best thing they could do, right? They're only pressure to do that. Yeah, 7 million years ago, they were bipedal. There's evidence that they were Sahelanthropus was the ancestor 7 million years ago. There's evidence that it was bipedal, but it wasn't bipedal like we are. They weren't walking upright. They were waddling. They were essentially... Have you guys ever seen a chimpanzee walk, right? You notice how they waddle, right? They walk like this, right? It's because their feet, they still had graspable toes. They still had graspable toes. Their feet weren't arched like ours. Their feet were not fit for walking that far, just from getting from tree to the next tree. And however, Sahelanthropus, there's evidence that in Chad, present-day Chad in Africa, now it's deserted, but back then there were lakes. There was lots of little lakes, chains of lakes everywhere. And we noticed that their bones are found near lakes. And we noticed that they were eating roots. Remember, they had to survive the cold. That's why they were able to eat the roots. They were eating aquatic plants. They were eating eggs from turtles and reptiles. And they were eating some shellfish, probably, from the waters, right? So this is when our ancestors became more opportunistic. They began, because they had to survive, they began looking for any food they could eat. Okay? This is what made us human. They were still living in the trees, right? They were still living in the trees maybe 80% of the time. But 20% of the time they were walking, looking for things to eat. And then 6 million years ago, Auroran, another ancestor. This guy, we look at their bones are very much like ours. They're definitely distinct from chimps at this time. We see that their thigh bones were slanted in a way that made them way better walkers. And now they could walk way further. These guys were adapted to walking for miles at a time. Their fingers were curved, though, indicating that they were probably still living in the trees most of the time. Maybe 60, 70% of the time they were in the trees, but 30 to 40% they were walking. So they were fairly efficient walkers. And the reason why you want to walk, why does bipedalism matter? Who cares, right? Well, there's a few advantages. Walking on 2 instead of 4 takes 4 times less energy. Because think about it. You're moving your arms, you're moving your legs, you're huddled. That takes a lot of energy versus just walking on 2. It's way easier. Also, another benefit, the sun. You're in the African sun. It's hot. And when you're crunched like this on all fours, you got the African sun beating on your back the whole time. Okay? That makes you very hot. However, walking on 2, the sun maybe hits your top of your head, but that's it. And so that's why we developed bipedalism. Another advantage is now you can walk and see further above the grasses. Remember, cats, lions, cheetahs, they were hiding in the grasses, right? Hunting for prey, hunting for apes. Our ape ancestors got eaten a lot by cats, big cats like lions, right? And so they walking upright was an advantage for them because they could see further, they could see animals lying in the grasses, right? So there were many advantages to walking on 2. That's why it evolved. That's why they adapted for that. Okay. Meanwhile, our chimp ancestors, the chimps were happy in the trees in the Western Africa, right? In the jungles. However, our ancestors were moving their asses. Okay. They were forced to evolve, man. They were forced to survive. So they had to grow bigger brains. Okay. 5 million years ago, the African Rift Valley, this is the peak of it, right? Now it's starting to get extremely dry in Eastern Africa. Very dry. Like, there's like no more water anywhere, okay? Our ancestors had to walk further and further. Ardipithecus rhomboides, 4.4 million years ago. We see their pelvic bone is broader and shorter. This guy was a great walker. Their body hair got thinner. Their sweat glands evolved more around their bodies. Now they were sweating more. They were walking more. They were walking in groups. They were walking in groups together. You can see here they still had graspable toes, but they were different. A bit more better adapted to walking. Okay. They also had social singing. See, they weren't allowed as much time to sit and pick at lice and socialize that way. Because if they did that, they'd get eaten by lions, right? Remember, they're walking in the savannas of Africa. Predators everywhere. So what do they do to socialize? Think about what could they do to socialize? Singing. They could use their voices. They could sing to soothe others. Singing was another key to our survival. They couldn't physically groom them. They couldn't physically groom others all the time. Singing became more important. Their vocalization became more complicated because of it. Okay. Now, 3.6 million years ago, Australopithecus afarensis, Lucy. This is Lucy. This is one of the key transitional fossils that we found in the 1970s. That was like the key evidence of of our ancestors that, were first human. The ones that gave rise to the first humans. Okay. So Lucy was the first ape ancestor. And by the way, yeah, this is the Toli footprints in Tanzania. Okay. In Africa, there was a volcano. It erupted. There was ash. Lucy walked around parts of northern Africa, Central Africa, Eastern Africa, and so we see their footprints everywhere. And here is a great example of it. And when we look at the footprint, we find something very astonishing. We find she didn't have graspable toes anymore. Her toes became more aligned with the rest of her toes. Her big toe became more aligned with the rest of her toes. And so her toes became flatter in terms of like this, right? More aligned. And they were extremely good walkers. They were walking about 70% of the time. They were walking. Because that's how rare it was to find food and water in Eastern Africa. Right? Their birth canals, we look at their pelvic bones and we see that their birth canals were large. They could walk even when they were pregnant. The females could walk even when they were pregnant. That's huge. That's a big advantage because now you don't have to sit there and wait for your baby, wait for the female to give birth. No, they could walk. They were mobile. Okay? This helped them survive. And why were their birth canals bigger though? Our heads were bigger. The babies' heads were bigger because they had bigger brains. Okay? And to support that birth, you had to have a bigger birth canal. Okay? But wait a minute. If the birth canal is bigger, doesn't that limit the amount of time that being could be pregnant? Because if it gets too big, you just can't give birth. Yeah. See, the babies began to develop more outside of the womb than inside of it. See, modern day chimpanzees, at birth, they're way more sophisticated than human babies. Human babies are blithering idiots compared to chimp babies, okay? Newborns. Why is that? Because we don't develop much in the womb. We're only there for 8 months. And we don't really develop that much in our brains because our brains are just too fucking big. And so that means that their babies had to survive outside of the womb for way longer in their vulnerability. And that means, what do we infer from this, guys? What do we infer? Family. They had very secure family units. They had a mommy and a daddy, perhaps a grandpappy and a grandmommy, all together helping each other, helping the baby survive, helping the baby grow and develop. This is when families began, essentially. We also see something very awesome in Lucy. We see that she has very small canines. Chimps have way bigger canines than we do. Why? Well, because chimps use those bigger canines to show off to other males, to fight for females. That's what chimps do. Chimps love to fight over females. But guess what? The fact that Australopithecus had small canines means they didn't fight for females that much. They weren't as aggressive. They were way more family oriented. Okay. So, we see that they have smaller canines. They are walkers. They were very efficient walkers. They were not as aggressive. They were more cooperative. Females likely begin choosing the friendlier males because the friendlier males could support the family more, right? The male could find food, right? See? Then, about 2 million years ago, Australopithecus gari. This guy was... When we look at this guy's fossils, we find often near their fossils we find bones of other animals. Why? Because they would scavenge. They would they would find a lion who ate upon another animal, right? The carcass would be sitting there, and Gari would get up, hide behind a tree, wait for the lion to leave, and he would come by the bones and scavenge, rip a bone off. And how did he get the meat off? He ate some of it, but he also used a little stone. This is the first species of our ancestors to use stones in 2.5 million years ago. They were using stones. The first stone tools were used. Now, albeit it was a very primitive stone tool use, right? They were just taking stones and breaking some of it. They would also use a big stone, like a hammer, smash the bone apart. And what they would do is they would take the little sharp pieces that came off of the bone. They would use that to cut off the meat. And they would also smash the bone in half, and they would eat the bone marrow. There is bone marrow inside of bones. Most other animals can't get to that, but our ancestors did. And the benefit of that is that there was lots of energy in those bones. Fat. There was lots of fat in that bone marrow. And so that was an energy source for them, okay? So, Gari starts using stones. He's a scavenger, right? He's a beginner scavenger. They weren't hunting yet. These guys weren't hunting yet for animals. They just didn't have the sophistication yet, okay? But, however, about 2.4 million years ago, Homo habilis, the first truly human, the Homo genus, this is the first human, Homo habilis, 2.4 million years ago, okay? This guy had a 30% larger brain than Lucy. This guy used their brains, okay? They had basic stone tools by this time. In fact, we find that in Africa, there's this Oldowan toolkit that we find near their fossils, where they didn't just have one stone, they had a kit. They had specialized stones, a big one like a hammer, another one, a sharpened one, another one. They would use them for different reasons, okay? So these guys became expert scavengers, okay? They had a hammerstone, the core, flakes. And the beautiful thing about stone tool use is that it served as a feedback loop for intelligence. Because when you use tools, if you have the capacity to use tools, well, you can use those tools to get more food. Get more food makes you become smarter. Getting more food allows you to look for other food. And that allows you to become smarter that way. Your brain becomes smarter and bigger the more you use stone tool use. And with the bigger brain, you can get better tool use, right? You can enhance your tools with a bigger brain. So it's a feedback loop of intelligence that initiated in these early habilis. 1.9 million years ago, Homo erectus. Now this guy was crazy. Okay, he was at this point they were masters at walking. These human ancestors were masters at walking by this time. They had longer legs, shorter arms. They lost their body hair almost completely. They had increased sweat. Now these guys used persistence hunting. So because they were so efficient at walking, they couldn't outrun cheetahs or an antelope, right? They couldn't outrun these animals, but they could outwalk them. So instead of chasing these animals, they would stalk the animal for miles. They would walk for miles stalking these animals, hiding behind trees, making them exhausted, right? Because remember, these animals would look back and see a human chasing it, and they would get scared and keep going, and then we just continue stalking them, right? Over time, in the African heat, they would collapse. They couldn't handle that much distance. See? Humans could. That's why we were able to chase them, stalk them persistently, and then find them collapsing in the hot sun on the ground, and then we would finish them off with a stone. You know? And now, this is likely how they did it. Some populations likely use this method. Others were just scavengers for the most part, right? And again, they weren't hunters yet. This wasn't really hunting. This was just an introduction to hunting. A precursor to hunting. 1.8 million years ago, Homo erectus begins following herds of animals out of Africa. The first humans out of Africa happened about 1.8 million years ago. The Homo erectus. And they began following the food, right? Following these big animals. And as the climate cooled down, they found themselves in Europe, in Asia. Okay, we see populations of erectus all over Asia, in Europe. But also, a lot of Homo erectus stayed in Africa. Remember, they originated from Africa. Okay, so they diverged away from Africa. Some stayed in Africa. Some went to Asia. Some went to Europe. 1.5 million years ago, we see evidence of them using hand axes. They were really using stones. Okay, they understood stones a lot. In fact, now, fire. Fire was another key advantage for humans. We would see lightning strikes occur in Africa and Europe, and we would see fire come about, right? Lightning does that to dry branches and trees and grasses. So we'd see a big fire. And humans, being the ones who walked almost everywhere, understanding the environment, we realized, wait a minute. It smells like something. Smoke. Roasting. We noticed that most animals run away from fires, right? Some of them get stuck in there and, they burn, they die in the fire. And people started to realize, oh my God, food. We smell the roasting of food in the fire, okay? And so they got closer and closer to the fire. They stopped running away from fire like other animals do. They started moving towards it. They started becoming comfortable with the fire. And they noticed that sticks were the ones that were on fire. So they got sticks. They brought sticks to it. And they started borrowing the fire from the brush fires. They would borrow it and bring it back to their camp, right? Bring it back to home base. Oh my God. You guys are fucking unbelievable with these fucking spam. Stop it and just fucking listen. So, they started borrowing fire, right? That was key to survival. 1.2 million years ago, it was common throughout much of Africa to cook your food now. Now they can cook their food. Now they could cook their plants. They can cook their meat. They could get more calories from those things. Cooking enabled easier digestion, right? It's way more easier. It's way easier to cook your food and digest it versus chewing all of your fucking food with your jaw, right? Also, tubers became way easier to eat, right? Now you can eat potatoes way easier when they're cooked. Okay? So, fire also enabled them to camp anywhere. Now they can camp anywhere they wanted to where there was a brush fire nearby, right? So they could travel further, they can travel in colder climates. Fire kept them warm. Fire also scared off predators. Fire was so important for us. Now, in the colder climates, happen to contain those larger animals, rhinoceroses, woolly mammoths. They all existed in Europe about a million years ago, and our ancestors were using fire to survive. Their jaws became smaller, their teeth became smaller, family units became more secure, more tight. Then 700,000 years ago, there was another wave, a migration out of Africa. Homo heidelbergensis. So those erectus that stayed in Africa, they became heidelbergensis. They started migrating around Africa. They started migrating out of Africa again, right? The ones who stayed in Africa became heidelbergensis. They moved out of Africa into Asia and Europe. And heidelbergensis started striking stones together, and they noticed that, oh, if you strike certain stones with iron stones, you get sparks, and those sparks would ignite fires in grass or bark. And so they started to make their own fires for the first time about 700,000 years ago. They started making their own fires. Then they started with that fire making, they began using glue. They would take bark and heat it up, and they found that it created a glue that they could use to make spears. Spears became common about 500,000 years ago all across Europe and Asia. 400,000 years ago, Neanderthals. Those heidelbergensis who stayed in Europe became Neanderthals. They were using spears. They were using fires. They were the bark. So there's certain bark that you can melt, and it can create, if you bury it, it can create a kind of glue. Okay. So now you have the heidelbergensis in Africa who stayed there. You have Neanderthals in Europe and Denisovans in Asia. Now, Neanderthals were cold specialists, right? They began adapting to the cold environments. They became stockier. They ate way more fat, right? They ate way more fatty animals. They had fur. They used their fur to cover themselves. Neanderthals were crazy. However, the humans who stayed in Africa, because Africa was a different climate, they were forced to evolve in a different way than the Neanderthals, right? They were still constantly adapting to survive, trying to find new ways to survive. And so the humans in Africa, in northern Africa, they were doing way more research and development than the Neanderthals. The Neanderthals, although it was a harsh environment, it was relatively easy to survive there versus Africa. And so the African humans became way more able to survive, way smarter, essentially. Those African humans, 300,000 years ago, they're migrating now into South Africa, all around Africa, and they become Homo sapiens. Okay, they have adapted so much that they become a different species, Homo sapiens. Now, these were a bit different than us. They were very, although we today could breed with those early humans, they were very different from us in a few ways. But about 120,000 years ago, those Homo sapiens, because of climatic reasons, they begin leaving Africa. Oh my fucking God. I can't stand these people. Stop and listen. Really. Okay, so 120,000 years ago, Homo sapiens, they were starting to migrate out of Africa for climatic reasons. Now, meanwhile, they were evolving in Africa while Neanderthals still existed, Denisovans still existed in Europe and Asia, right? So the sapiens who coming out of Africa, they were met with Neanderthals. There were 3 different species living on the earth at the same time. Well, actually 4 or 5 different human species living at the same time 120,000 years ago. Fascinating. And so the sapiens were trying to come up to Europe, but the Neanderthals kept stopping them. The Neanderthals actually started attacking sapiens. Okay, now it wasn't like a battle, right? It's not like a war, but it's like there were isolated pockets of Neanderthals killing off sapiens. In fact, Neanderthals would eat sapiens. They would actually cannibalize each other. But for thousands of years, this kept happening. Sapiens just couldn't reach past this part of Europe. They just couldn't get past it. Until about 70,000 years ago, a volcano erupts. A lot of humans die. Neanderthals take a hit. Africans take a hit. But in Africa, remember, because there are sapiens still in Africa, right? Those guys were developing very sophisticated bow and arrows. They were developing spears that you could throw, javelins, right? Their technology was way more advanced than anything the Neanderthals had, right? And so these are the humans about 60,000 years ago. They were the final wave of humans to leave Africa, and they were able to defeat the Neanderthals, get past them, and they were the ones who became us. You know, those are our ancestors. They mated with the Neanderthals. They didn't kill off all the Neanderthals. A lot of the sapiens just interbred with the Neanderthals, and we absorbed them in our DNA. In fact, most people living today have like 1 or 2% Neanderthal in them, especially if you live in Europe or Eastern Asia. So, yeah, about 40,000 years ago, humans literally began migrating across the entire planet. By 20,000 years ago, they were everywhere except for Antarctica. And about 10,000 years ago is when the white skin gene evolved. Mind you, all humans were dark-skinned until about 10,000 years ago. Same with blue eyes. Why? Because of agriculture. Not because of the cold. Not because of the lower sun in the north, right? See, humans in Northern Europe were able to consume lots of vitamin D rich meat. And so, although there was less sun in the north, they were able to get their vitamin D from the meat. And so they didn't have to adapt whiter skin to get more vitamin D from the sun. Because that's how you get vitamin D, from the sun. The whiter your skin is, the better you are at absorbing the sun, absorbing vitamin D and producing it, synthesizing it in your body. Now, but about 10,000 years ago, agriculture, with the advent of agriculture, right, people began eating just plants. They began just eating plants and grains, bread, potatoes. They were farming that. They were no longer eating all that meat. You just couldn't eat that. You couldn't eat meat if you wanted to in certain parts of Europe because there just weren't enough wild animals to hunt. So they depended on all the plants. They no longer ate meat. And so the vitamin D levels went down, but the ones who had the whiter skin adapted better because they can get more they can get way more vitamin D by producing it in their bodies. And so that gene spread. It became very prevalent in Europe about 10,000 years ago. That's why people have white skin. Okay. And again, if you're a European, if you have European blood in you, you have 1 or 2%. Neanderthal DNA in you. I definitely have Neanderthal DNA in me. Um, but the beautiful thing about that is that it allowed us to it allowed us to survive in the cold, and we were able to, by getting their DNA, we're able to now survive certain viruses that we never saw before, right? When we interbred with them, we're able to now survive viruses better, right? So Neanderthal DNA was integral for our survival. If we didn't have that, we would, who knows what would happen, you know? So here we are today. Now agriculture is everywhere. Okay, now we have literature, right? We can now write things on paper. We can share knowledge. We can now communicate digitally, and we come from all that. That was our history. That's how it all happened. That's amazing. Isn't that amazing? Learning about the past, I think, enhances your appreciation of who you are, who we are, of people. We are amazing things. And so, yeah, understanding the past is so important, I think. I think understanding our evolution is so important, not just because it's true, but because there's something profoundly deep about that. There's something profound about our origin as the way science reveals it to us and not religion. All right. Do I burn because my ancestors didn't get as much UV, like global warming stuff? No. Burning, UV levels have are not significantly different. Your skin does that because your ancestors were not in the sunlight that much. That's why. They were inside. They were not outside that much. It was cold. They didn't have air conditioning. They didn't have heat, right? So they were inside, in caves. They were like in huts. They were not living outside most of the time. You know, they were huddled near fires. They were not. They were not just like in the open with bare skin, right? They also had lots of clothing on them. You know. Yeah, your European ancestors were doing that, right? But again, people in Africa, people in warmer climates, they weren't doing that. This is also why a lot of, especially African people, have higher rates of lactose intolerance. Because agriculture, domestication of cattle didn't happen in many parts of Africa. And so they weren't adapted to it, to consuming milk or dairy, like people in Europe and East Africa were. Okay. Amazing history. Amazing how there's an explanation for everything, through science. You know. Yeah. Never heard history explained like that. I like it. Yeah. Care to speak on Asian populations having the most Neanderthal DNA? Yes, that's a great question. Why is it that when we look at the amount of Neanderthal DNA people have, it's actually the East Asians who have the most, not Europeans? Why? Well, the answer is when when um when sapiens first moved into Europe, they bred with the Neanderthals. But some of those populations of people who already bred with the Neanderthals then moved into Asia, where in Asia there were other isolated populations of Neanderthals too. And so those populations got a double dose of Neanderthal DNA as they moved into East Asia. And so this is why East Asians actually have the most Neanderthal DNA in them. The same with the Denisovans. Denisovans were mostly in Eastern Asia. People in Australia, the indigenous Australians, they have the most Denisovan in them because they were isolated for so long with very little exposure to other DNA. Amazing. Amazing stuff. Hope that answers your question. What started the Big Bang and what started that? Well, when you ask the question, what started it, it's a very difficult thing to say because our understanding of causality breaks down at the Planck length, at the Planck energy scales. When you say what started it, that doesn't make any sense anymore at a certain point in physics. But to answer your question intuitively speaking, we have quantum mechanics to answer this question. Essentially, there is a quantum field, an inflaton field that exists that has potential energy. However, these fields can fluctuate in certain ways randomly that they give rise to something called an inflaton field, and it expands and creates inflaton particles. It gives rise to a certain Big Bang reaction, right? And you get a Big Bang. You get a Big Bang. In other words, you can get a universe from an empty from empty space. Empty space itself contains energy that gives rise to universes. This is called inflation. But again, this is just one theory, right? We don't exactly know every single aspect of how the Big Bang happened, but we have ideas. None of them need God, right? So there's no need for a God to explain anything. What came before the Big Bang? Again, when we ask ourselves what came before, that implies a time. But time doesn't, our understanding of time breaks down at a certain point in quantum mechanics. It just doesn't, causality and time, they get very fuzzy at these levels. And so maybe there just was space-time, and that's it. That's all there ever was. There was no before that. The Big Bang is not the beginning of time, by the way. The Big Bang is not even the beginning, necessarily. It's just a phase the universe goes through. So it may be that the universe always existed, but the Big Bang was just something that happened in part of the universe, right? The part of the universe that we exist in. And there may be other Big Bangs out there, all around. There may be other Big Bangs. It's crazy that we exist. Yeah, it's crazy that we exist when you think about it. You know? How do scientists measure the age of the universe? Well, we look at many different reference points. Right? We look at galaxies, obviously. We build a model of time, right? This is what the Big Bang essentially does. We look at a model of the time in which it takes for galaxies to form. We look at the wavelengths of light that they emit. By looking at the wavelength of light as it redshifts, we can tell how old it is. We have a gauge for what the distance is in the universe. We also can look at the CMB radiation, right? We see the cosmic microwave radiation all around us. There's a map of that, and that tells us that the universe is that old. You know, based on the distance, based on the CMB, we get a good gauge as to how old the universe may be. Now, again, the Big Bang is not the beginning. So when we say 14 billion years, that doesn't mean the universe began 14 billion years ago. There may very well be time before that. It's just our local universe, as we know it, expanded 14 billion years ago. That's all the Big Bang means. All the Big Bang is talking about is a moment in time in which the universe rapidly inflated. What do you mean other Big Bangs? Well, beyond our universe, there is beyond our local universe, there may be other Big Bangs occurring all the time. Because there may be quantum fields in which you have energy and you have a rapid a quantum fluctuation giving rise to those Big Bangs. And so you have many different Big Bangs. Yeah, a multiverse of Big Bangs. Yeah, that's very plausible that that's the case, you know? Local universe as in beyond, like outside. Yeah, the universe that we observe is just what we observe. It's not what everything is. See? We don't see everything. In fact, we're barred off from seeing everything because light has a speed limit. Light travels at a finite speed, and so we don't see beyond the cosmic event horizon. There very well may be other Big Bangs beyond that. How did consciousness evolve into us? Well, consciousness is tied to eyes in the first animals, right? The first animals evolved eyes to help them see food and see predators. The brain, the neural network, co-evolved to process those signals. And so it's likely that the brain evolved to process all the sensory systems in the body: eyes, ears, nose, right? Body mapping, right? Sense of self awareness. That all happens in the brain. And so the brain clearly evolved to process the senses of the body. And that's what consciousness is. Consciousness is just that activity happening in the body, that bioelectrical activity that makes you able to sense the world. And that's all consciousness is. What's the cosmic event horizon? Well, that's the point in space in which light cannot reach us anymore. Anything beyond that event horizon, the universe is expanding too fast. The universe's expansion is superseding the speed of light. So anything trying to come in just will never be able to. Anything coming out will never be able to. That's just where all light stops. All the things we see stops. Yes, as time goes on, we'll be able to see more, but there's a point at the very end of this in which, again, we'll never be able to see because light will never be able to reach us. Just the space in between us and them is just so expanding so much that light will never reach us. right? That's what's happening. Space itself is expanding so much that light coming from the outside towards us can never traverse that space. It's just too much space for that light to travel through. You know, so there are different event horizons in the universe, right? There's different horizons, but the ultimate one is the one in which we'll never be able to see anything more because of the expansion. Why are they different? They're different because of the, like you were alluding to before, how far away the things are, right? There might there might be an object just beyond the event horizon, right? In which its light has just enough time to reach us. So every bit of expansion allows us to see more of that object. Because again, the further away it is, the faster space is moving. It's a freaky thing, but see how see how our space here is not moving, it's not expanding. We don't sense it. Is right? Space is only expanding for things farther away. Gravity, the electromagnetic forces, these supersede, they overcome the expansion force of the entire universe. So, we're able to exist without space being expanding here. But as you go further and further, space expands more and more. According to science, what came first, chicken or the egg? Well, when you say first, what do you mean? There is no such thing as first in evolution. Look, if you try to point, you're like, well, where's the first human? Okay, well, let's go back in time. My grandpa, his grandpa, his grandpa. You go back all the way back a million grandpas, you realize, oh my God, there's just more grandpas. But every grandpa back is a bit different than the other one, right? Every grandpa is a tiny bit different. And so enough grandpas back, you get something very different, like a chimpanzee, And so asking where's the first doesn't make any sense in evolution. But to answer your question, when you say first, you likely mean what evolved essentially first, right? Before. Well, again, if you say, well, a chicken has to lay an egg, so if you say that a chicken has to lay the egg, so clearly the chicken came first, but the chicken had to come from an egg, right? Well, like I was alluding to with the other example with humans, if you go before the chicken, there's a proto-chicken. There's the precursor to the chicken. Chickens and eggs co-evolved. And so you go back in time, you find that you'll always find a chicken and an egg until you get to a certain point. A certain number of them are going to be a bit different, right? Significantly different. The back you go, the further back you go. Very complicated to intuit, right? But once you understand evolution, it makes a lot of sense. Is it kind of messed up that we're linked to chimps? I think it's amazing that we are. Does gravity affect gas? Absolutely. We wouldn't be able to breathe without gravity affecting the atmosphere. That's what keeps the atmosphere full of pressure. Gravity. Gravity on the Earth attracts enough gas, enough density to give rise to a pressure. Are you atheist? Yes. Do I believe in aliens? I believe that they're very plausible because based on the sheer number of life of planets out there, right? People forget that Every star you see likely has a planet orbiting around it. And there are more planets than stars in the galaxy. There could be trillions of planets in our galaxy. One galaxy. And there are trillions of galaxies. So the amount of possibilities are literally endless. Plus, life emerged fairly quickly on the Earth, right? Cosmic timescales, 100 million years is nothing. So we know that life is easy. Life is easy to make, just basic ingredients. And so the fact that life can exist easily on planets like the Earth, and the fact that there could be billions of Earth-like planets out there, it's very plausible. Life is out there. Evolutionarily, why are humans one of few species to have enlarged breasts? Attraction. It's a sign of fertility. It's a sign of fertility, that somebody is going to have offspring. They're going to have healthy offspring. Is it true that there are more stars than grains of sand on the Earth? Yes, absolutely. If you take a handful of sand on a beach, it's about 10,000 grains of sand. That's about how many stars you can see in the night sky in a dark area. So the number of grains of sand in your hand already compares to the amount of stars in the sky. But there are about 100 or 400 billion stars in our galaxy. Times that by trillion to a couple trillion galaxies, that's 10 to the 22 stars. 10 with 22 zeros. And there are far more stars than there are grains of sand on our beaches. On all the beaches of the Earth combined. Amazing. This is scary, but yet so important. Yeah, it's scary because you've been taught that you're the most important thing in the world, and we humans are somehow different than the nature we exist within. We have somehow separated ourselves from nature as we live in our societies, glued to our phones, glued to society. We don't think of this very much. But once you do, you become comfortable with it, right? There's nothing to be scared of. It's the end. At the end of the day, there's nothing to be scared of. And if you feel insignificant, good. There's nothing wrong with that either. It's okay to be insignificant in the grand scheme of things. But it's also important to realize that you can make your own significance by the things you do. The people you love, your family, your friends, that's all significance. Even in the grand scheme of things, yeah, it's not that big a deal. But to us, in our lives, it is a big deal. Having friends and family is very great. It's a great thing. It's a precious thing. It's a precious thing to have family and friends. So, cherish it. There's no reason to get doomy and gloomy because the universe is big. Let's say chimps could be attracted to breasts too, but theirs are not enlarged. Oh, I gotta go soon. Chimps could be attracted, but humans have a different type of sexuality than chimps, right? We have a higher level processing things. Chimps are way more instinctual in the way they do things, right? In the way in the sex they have. For us, it's a different story, right? We are far more selective. We have far more complexity to us socially. And so that's why we've developed different, like, for example, our faces evolved to be more inviting and warm, versus the other animals. Our expressions evolved because they co-evolved with our brains. It's fascinating. It's fascinating. It's very, but it's yeah, it's a good question. It's very more complicated than that, though. Just it's not just about attraction. It's a bit more complicated. Why you talk about chimps when you can talk about bonobos? Bonobos are essentially chimps. I mean, very little difference. Scariest part to me is that we don't even have free will. Why? It's not scary. Again, I understand you're scared, right? You're looking at a part of reality you've never seen before, right? You're poking at it. You're peeling away a layer of reality you've never seen before, and so it's scary. But, yeah, free will, whether it does or does not exist, it has no effect on your life, right? If you think about it, it's simple. All this stuff we're talking about here are just thoughts, right? This is all just data, information. That's all it is, though. It doesn't actually directly impact your existence. They're just thoughts, right? It's good to learn these things, but it's also important to ground yourself and don't get stuck in all your thoughts, right? Don't get stuck in all these existential thoughts. Oh my God, free will, God, and oh God, what's our purpose? Like you're gonna go crazy if you get stuck there, right? It's always important to go back and ground yourself and realize it's all just thoughts. It's all just information. All that's really real is you and me, the world you observe, the stuff that's tangible. Right? That's all that's really real. Everything else is just information. How is there a picture of the Big Bang? Great question. Well, the answer is the Big Bang happened everywhere in the universe. The Big Bang happened where you're standing. The Big Bang happened at every point in the universe. And so what that means is that the entire universe as it is today existed at the Big Bang. It was just smaller, hotter, and denser. Think about it shrinking, right? The universe was still there at the Big Bang. It just expanded since then. And so the point is that the energy that was at the Big Bang is still existing today. However, it was in a different form back then. Because the universe expanded, that energy got less intense. And so what that means is the energy at the Big Bang may have been gamma ray form, right? Very intense light, but because the universe expanded, its energy decreased and it became microwave radiation. That microwave radiation is the stuff that's all around us. A lot of it is piercing through your body right now. That radiation, that microwave radiation from the Big Bang is right now moving through your body, moving through your television, moving through your house. Because again, the Big Bang happened everywhere, even where you're standing. And so when we take the picture of the CMB, what we're doing is we're using our telescopes looking at the entire universe around us. It's really a 360-degree photo. Okay? It's a global photo of the universe. That image is showing us the intensity of the microwave radiation everywhere. That radiation is the picture of the Big Bang itself. Just as we see it today, as the energy decreased. It's the remnant radiation from the Big Bang. Hope that makes sense. All right. So it was so intense it's still emitting energy. No. Nothing is emitting energy. The energy is just there. It was just back then smaller, hotter, and denser. The universe as a volume was smaller, hotter, and denser. right? So that energy was way more intense because it was a hotter area. It was a smaller, denser area. As the universe expanded, that light became stretched. Stretching of light makes it lose energy. It went from gamma ray to microwave, one of the longest forms, right? Think of a thing stretching like that, right? This is gamma ray, this is gamma ray, it stretches out into microwave. And so that microwave is what we see. That's literally light from the Big Bang. Do you support Bitcoin mining? Yeah, there's nothing wrong with that. Religion is a cowardly way to get simple answers. Yeah, look, you know, that once you learn science, once you understand the world more, once you become an atheist, you have this initial urge to want to go, oh, fuck religion. Religion's stupid. You gotta be stupid to believe that, right? You become an angry person. We all have that. We all have that initial urge to say that because we're doing a comparison in our minds. It's like, wow, look how ridiculous religion is. Look how awesome this is. In reality, look, there are reasons why people are religious. There are maybe not good reasons, but there are natural reasons for why people are religious. It's okay to be religious, right? It's part of human nature to want to be correct, to want things to be simple, right? We like following others. It's easy. Hey, let me copy you on your test, right? Let me do what you're doing. We all do this, right? We all grow up doing this with our parents. Let me follow my daddy, right? We all copy our fathers and mothers. It's natural instinct to look for something to copy and say, yep, I have the answer. It's here in the Bible. And so my point is we should not be belittling religious people, right? Oh, you're stupid. No, we should not be saying that. Instead, we should be helping them understand the world. Calmly, patiently helping them understand how the world actually works according to science, according to the data. That's all. I, you know, to sit there and say, yeah, religion's for stupids, really doesn't help anybody, So. Yeah, I understand that religion can cause harm. I agree. But again, it's like, you know, look, there was a time where I was religious. And yes, unbeknownst to me, back then, I was causing harm. But does that mean I was undeserving of love and patience and kindness? No. Even though I was religious and wrong and maybe causing some harm, I still deserved to be loved. I still deserve to be treated with compassion, right? That's how I treat all people, right? No matter if you're religious or not. And the way I look at religious people is, oh, okay, he needs to learn something. He should learn something. I can offer him help. I can offer him learning, education. That's all. I don't see it as, oh, they're stupid, or they're idiots, they're sheep. No, I say, hey, how can I help you? How can I deeply affect your life and change the way you see things in a better way? Don't you think in a way religious people can be happier because ignorance is bliss? I don't agree with that. I don't think ignorance is bliss. Because, look, you can be happy in any state. Happiness does not mean you're just ignorant and doing nothing. I think happiness means you're just okay with whatever there is. You just accept whatever happens. I think that's really what happiness is. It's the pure acceptance of whatever happens. You know, and so the way I see it is, you can have knowledge and be happy. You can have lots of knowledge and still be very happy, because you can know things and just accept that that's how the world is. I think where the unhappiness comes in is when you expect so much. You're expecting so much from the world. Okay. In fact, I would say religion inspires that expectation in people. They have so many expectations, right? But again, you can be happy. You can be happy with knowledge. You can also be happy as an ignorant person. Happiness is attainable for anybody. So I don't agree that ignorance is bliss. I do agree, though, that it's a bit harder at first when you're learning things. It's a journey, and it might be uncomfortable to do that at first. But just like it is uncomfortable to ride a bicycle with the training wheel, as you get used to it, it's great. It's freedom, actually. That's how I see it. I think knowledge really is freedom. And happiness is merely a way that you're responding to things. It's not a state where you can only have if you're ignorant of things. That's all I can say. So, yeah. Yeah, it's like eating a bunch of food, right? It's like eating a bunch of food and getting a stomach ache. That's how knowledge is. If you take too much in, you get sick, right? Take it slow at it, slowly digest it, slowly learn, slowly come to grips with all this. You know, there's a shock that happens. If I were to go up to somebody like my 90-year-old grandmother who doesn't understand any science, right? She wholeheartedly believes in God and all that. If I were to tell her all the things I know right now in like one night to her, her brain would explode. Right? Her brain would explode. Like it just is not compatible with that type of person. It takes time to learn things. It takes time to adjust and adapt. Okay. And so yeah, it's like that's what you think is unhappiness, right? Because you're shocked. Oh my God, this world is so big, it's so vast. I'm so insignificant. I just wish I didn't know this. Well, that's your initial reaction. Again, just like a toddler in school for the first day of school. It's shocking. But by the time you get to 12th grade, it's like, yeah, I do. It's second nature to me. Right? That's how I see knowledge. You adapt to it. You learn. You become comfortable with it. In fact, I'm at a stage where I'm comfortable with being insignificant. I'm comfortable with dying and nobody caring about me. I'm okay with that. I've grown comfortable with that. I've grown comfortable with the fact that all this might be gone when I'm dead. The universe might not exist anymore when I'm dead. That's okay. That's okay. It's okay. Either way, if I go to heaven, great. If I don't, great. Whatever happens, happens. I think that's happiness. Just accepting whatever happens. So yeah, I think that's the way I see things. Yeah, we have that urge to want to be remembered, and we have that urge to want to leave a legacy, and we have that urge to want to live forever. That's why we invented religion. Literally, it helps us feel like we live forever. We all want that. Deep down, we want that. It may be true. Maybe it's true. And that might give you comfort to believe that. But I think there's a lot of freedom and power in just fucking looking death in the eyes and saying, I don't care. Whatever happens, happens. There's so much power there, right? Accepting whatever happens. That's a lot of that's powerful. So, yeah. You agree that we're simply the universe experiencing itself. Yeah, science is like the poetry of reality, as Richard Dawkins said. Science is the poetry of reality. Science science is a way of understanding poetically your place in the cosmos. We're stardust. That part of you is you're just borrowing stuff from the universe, temporarily coming together to be a human. And eventually your atoms will go back into the universe and go into space in the universe, whatever. That's amazing. That's poetic. That's beautiful to recognize we're fragments of the world coming together to experience this place for a moment and then going away. It's amazing. It's absolutely incredible. You know? It's wild people fear death, but do just everything to get there faster. Yeah, no, yeah, fearing death is natural and normal, but yeah, some people, what they do is they cloak all the bad things with God. God is going to take care of it, right? God is going to help me. That's a crutch, I think. I think that's, I think that that's a very limiting way of seeing the world, you know? We are stardust. Yeah, exactly. The atoms in your hand come from different stars, probably from the atoms in your right hand. Our solar system formed not just through one star, but through multiple stars that have recycled their material for billions of years. Well, no, again, two atoms in your hand might come from different stars, but the point is that generally speaking, right, the atoms in different parts of your body come from different stars. And so stars that, by the way, had to live there, had to exist for millions of years themselves, explode, create the elements, oxygen, hydrogen, helium, carbon, nitrogen, all that stuff, nitrogen in your blood, iron in your blood, the hydrogen in your body, the calcium in your teeth, in your bones. All that had to be forged in the cores of stars that then exploded after millions of years. All that gas and dust went into space. Then that had to collapse back into a disk, spin, and then turn into a star. And planets. We are fragments of that solidified stardust. So you literally carry stars with you. As Carl Sagan said, you are a way for the cosmos to know itself. We are a way in which the stars can know themselves. Absolutely poetic. And we don't need God for this, right? We don't need God. to understand the beauty of life. It just is naturally beautiful, you know. And by the way, knowing more about it makes it more beautiful. That's why I don't believe ignorance is bliss. All right, folks.